Alright, so here I'm going to write some equations. Here we have density is equal to mass divided by volume. Density is the Greek, density has the Greek symbol rho, which is a curly p. It stands for density. Mass needs to be measured in kilograms, and the V stands for volume, and it has to be measured in meters cubed. Now let's do some conversions. So if you imagine a cube with the side 1 centimeter, that means the volume will be 1 centimeter cubed. However, let's convert each of those centimeters as 0.01 meters. So the volume of that centimeter cubed will be 1 centimeter cubed, but because we're converting each of those lengths into meters, we're multiplying each of those three lengths together, we get 0.1 meters all cubed. And because we have 0.01, we just 10 to the minus 2. 10 to the minus 2 all cubed will make 10 to the minus 6. So the conversion is that 1 centimeters cubed is 10 to the minus 6 meters cubed. What about the area? Now, if we have a square that has lengths 1 centimeter each, that means each of those lengths will be 0.01 meters, and then when we square it, we get 10 to the minus 4 meters squared. So what are the units for density then? What are the units for density? Right, so now we're doing specific heat capacity. Remember that E or Q stands for heat energy. Heat supplied to a substance needed to raise a degree of 1 Kelvin or 1 Celsius, raising it at temperature. So M is the mass of that substance, C is the specific heat capacity of that substance, and delta T is the change in temperature. And this is the specific latent heat, where it is the change of state. So in this case, V, SLHV, is the specific latent heat of fusion. What's F? IE stands for, it doesn't stand for Internet Explorer, it stands for internal energy, and internal energy is the sum of kinetic energy plus potential energy. And pressure is equal to force divided by area, and the force has to be perpendicular to the surface. In this case, rho is density, G is 9.81, h is height. So if you imagine a volume of water that is at a height h above a certain point, here the rho is the density of the fluid, then the pressure below that point would be rho g h. Here, this is Boyle's law. So the pressure is inversely proportional to the volume, keeping the same temperature. Because if you were to keep the same temperature and you are increasing the volume, then the particles will have more space to spread around. Then the collisions between each other and the collisions between the wall will be much less. Here, what is P? So here, P is mass times velocity. Mass is measured in kilograms. V is measured in meters per second. The triangle means change, so the change in momentum would be mv minus mu, change in momentum. V will be the final velocity, u will be the initial velocity. divide both sides by t. So on the left hand side we should have divide by t as well, on the right hand side divide by t. Now if we just take the m out, and then we get on the right hand side v minus u divided by t, that is the definition of acceleration, because acceleration is the change in velocity over time. So F equals ma. E, work done, or energy. So work done is equal to force times distance. Force applied in a direction applied times the distance travelled. And power is equal to energy over time. So if you have more power, that means more energy is being used up. Hooke's law, F equals kx. Here we have the negative, meaning the opposite direction to the weight. And the energy stored in the spring is equal to half kx squared, where k is the spring constant, x is the extension energy stored in the spring. Moments. So the moment is a turning effect. If you have a pivot about something, if you have a pivot where something is rotating about and you apply a force a distance away from the pivot, it will rotate. So it will be force applied times the perpendicular distance to the force applied. V equals IR. Here voltage is equal to current times resistance. Current is equal to the rate of flow of charge. Voltage is energy per charge. So if you times the current, which is charge over time, multiply that by energy per charge, the Q's cancel out. You end up with energy over time, and that's power. So therefore power is equal to current times voltage. So speed is equal to distance over time. I'm going to use s as distance or displacement. So here we have velocity is equal to displacement over time, or speed is equal to distance over time. So what is the definition of acceleration? Acceleration is the change in velocity over the time taken. So the change in velocity is v minus u, t is just t, so therefore a is equal to v minus u over t. That's acceleration. Now we need to be able to convert 1 miles per hour into meters per second. 1 mile is about 1.6 kilometers, and 1 kilometer is 1,000 meters. So 1 mile is 1,600 meters. And remember, per hour is you need to convert that into seconds. So 1 hour is 60 minutes. 60 minutes is 3,600 seconds. So if we divide 1,600 by 3,600, we get 0.444 recurring. So that's the conversion. 1 miles per hour is 0.44444444444 meters per second. This is a speed time graph. So if you have the initial speed u, increasing speed with uniform acceleration, and ends with a speed v, final speed, the area under the speed time graph would be the distance traveled, or displacement. So this is the area of a trapezium. The parallel sides is u and v, so you find the average of those two times by t, you get the distance. So half brackets u plus v times t equals s. Now there's no other equation that you need to know. V squared equals U squared plus 2AS. Now you have to eliminate T in this case. So you'd rearrange the equation for acceleration, change the subject to T, and then put that T into the equation above, and you should get V squared equals U squared plus 2AS. Bill, F equals Bill, force is equal to B is magnetic flux density or magnetic strength, I is the current, L is the length, N is the number of turns, V is the voltage. P is primary, S equals secondary. And kinetic energy half mv squared, potential energy is mgh.